Okay, so this is the example in the book. It's what you chose, so that's what we're going to do. But is that really one of the problems in the section? That was a good choice, except it's redundant with the example, okay? But, and I messed it up because I didn't write the t squared here originally. Then I said, well, your p of t is t, right? Okay, because you have this. Well, it's not, because you got to have the coefficient of 1 for your y double prime. So the equation is y double prime minus, I'll write it as 1 over t times y plus 1 over t squared, and that's the y prime. Okay? Make sense? So now applying the reduction of order, we can go through all these steps, and as I said before, it's good to do that when you're actually doing it, okay? But if we do, we're going to end up with this, if we do the algebra correctly. Okay? So we're going to skip some steps. Let's do our premise. Let y2 equal y1 times u. Okay? Then we skip a bunch of steps because we know from this that we're going to end up down here. But I wouldn't memorize this. I wouldn't memorize this. I wouldn't memorize that. You know, work through the steps. But for the sake of time, I know you can work through those steps. You're going to end up with y1 u double prime plus 2y1 prime plus py1 u equals u prime equals 0, where p is your negative 1 over t, y1 is t. Okay? So we're going to get y1 u double prime. That's going to give us t u double prime. And then 2y1 prime is just 2 because y1 is t and y1 prime is therefore 1.
Why does q not have any impact on the solution?
What is what now?
Why does q, the function,
It doesn't matter for the reduction of order. Q influences what this function would be. Once you have this function, for reasons we really don't want to take the time to explore, but it's worth thinking about, it becomes irrelevant. Okay? And I'd have to think to explain why, and since you asked, I'll probably think about it, but for right now, we'll just stick with this. It goes away. And you look in here and you see why. I mean, it goes away because this goes away, but that's not really a very satisfying explanation. Except this does show that it goes away. The Q has no influence. So the only influence Q had was on determining this, but of course this is important for determining your second solution. So whether Q is there explicitly here, it had its influence in determining y1. Okay? So it's kind of hidden, but it's kind of still there. Okay, anyhow. Then we have plus py1. Well, p is negative 1 over t, and y1 is t. So I put a plus there, but I'm just going to, it's negative t. Negative 1. Okay? Again, py1 is t times negative 1 over t, which is negative 1, right? So you have t u double prime plus u prime equals 0. You make your change of variable. Your book uses v, I use w. You get t w plus w equals 0, easily separable or first order homogeneous, right? So the w we'll use the, and that's W prime. I guess, just for completeness, I'll write this as 1 over T W. Okay, write this way, okay? So that we can see that W is e to the negative integral of 1 over T dt.
How come you leave out the A part? Like
The A part.
usually it would be A e to the negative integral.
No, that's when you're doing a trial solution. There's no trial solution involved here. Your trial solution is always going to have a constant, okay? Because your general solution will have a constant there. That's not the case here. That doesn't work, and you can kind of test that. Anyhow, this equals e to the negative natural log of t which is 1 over t. And you can check that. The derivative of 1 over t is negative 1 over t squared. This will give you plus 1 over t squared. It's 0, so that u is the integral of w. I'll put the t dependence in here since we know what the variable is. Integral of 1 over t dt, which is a natural log of the absolute value of t. So now our second solution is what? Well, our assumption was y2 is y1 times u. So we multiply our y1, which is t, by this, which is natural log of t. So y2 is y1u, which equals t natural log of the absolute value of t. Our solution set, got my L and my N together there. Solution set is then t natural log of the absolute value of t. Wrote the t a little close to the L there, so I put some parentheses around this. Okay? And you can verify it. You know, you plug this in and you find it's a solution. You plug this in, you find it's a solution. You do the Ronskin, which is very obviously going to be non-zero, but you write it out just to be sure. Okay? So, don't forget, test and verify.